Alright, exam 1, problem 4. You have two resistors of 100 ohms and 50 ohms in part A. If you attach them in parallel to a 10 volt source, what will be the power expended in each resistor? Well, I'm going to draw this for a second. So here you go. You've got your 10 volts, right? Plus, minus 10. And then you got one resistor, it's 100 ohms, one resistor that's 50 ohms, right? So 100, 50. So the thing here is when they're in parallel, you have 10 volts across this one, and you have 10 volts across that one. So with 10 volts across both resistors, the power in each is actually pretty straightforward to calculate. So it's just the power, and say the 100 ohm, is V squared over R, right? We're going to be using V squared over R, and so it's a 10 squared volts. 10 volts squared. Well, I got to make that a little clearer. 10 volts squared divided by 100 ohms is just going to be 1 watt, right? And then power in the 50 ohm resistor is going to be the same thing. It's V squared over R, so that's going to be 10 volts squared divided by 50, right, divided by 50 ohms, and that's going to be 2 watts. All right, so in part A, we get 1 watt and 2 watts as the power expended in the 100 ohm and 50 ohm resistors, respectively. Okay, so in part B is a little more complicated. Part B, they're attached in series, right? So that means we have our power supply, and then we have 1, 2 resistors. And the total of this, since they're in series, is pretty trivial. The total is 150, right? So what these resistors shared in common in the first case, in the parallel case, they shared a voltage in common. What they share in common in series is they share a current in common, right? They share a current in common. So the current, I equals V over R, right? V equals IR, I equals V over R. So that's going to be 10 volts divided by 100 ohms plus 50 ohms. They add directly since they're in series. So that's 10 over 150. Oh, what is that? 0.133 or something, or point equals 10 over 150 is, I was twice as large as that. Okay, 0.067 amps. 0.067 amps. All right? And so, now we want to use power equals I squared R, because we have the current through both of them, right? Before we had the voltage across both of them, now we have the current. So 0.067 amps squared times 100 ohms, okay, equals that squared times 100, so 0.44 watts. And then in the 50 ohm resistor, .067 amps squared times 50 ohms. All right, so that's going to be 0.22, but square times 50, 0.22 watts. Okay, so when they shared a voltage in common, the 50 watt had twice as much power expended in as the 100 watt. Now that they share a current in common, the 100 ohm has twice as much energy, power expended it as the 50 ohm. And that's it for problem 4.